How's it, Jordan here? In this video I'll be showcasing my racing wheel. As you can see, it's of the finest quality. I'm using a ice cream container lid as the wheel. And this wheel, it has steering control and it has throttle control. Fancy. Now, as you can see, I'm just powering it with my power supply. I'm feeding 3.4 volts to 5 volts on the ESP32C3 microcontroller, which is the microcontroller I'm using. So as you see, we have two blue buttons, and if I press the top one, we can drive forward, and if I press the bottom one, we brake and then reverse. By merging them, we can do some cool tricks. Now, just like a keyboard, you must kind of feather the throttle a bit if you don't want to go full speed. Eventually I'm going to add a joystick module, very much like this, except this one is broken for whatever reason, and that will make it so I can use that for throttle control. It's a bit weird, I don't know why it's broken, there's something wrong with it though. But anyway, I'll get a new one and I'll attach it and remove these two blue buttons. Then what I'll do is, there are a few problems with this. Okay. Hang on, let me just fix the camera. Okay, I just fixed the camera. Bit of a weird issue there. Anyway, so as you can see here, one of the issues is that the wheel snaps. As you can see, it's quite snappy. And the way you can fix that is I'm using a rotary encoder, and I think I bought it for like $40. So it's a good part and it works extremely well, and it hasn't failed so far. However, the problem is with it is that it snaps. It does quite big increments. So what I'm going to set up is a gearbox. So the axle, it rotates the rotary encoder faster, which means I can make the rotary encoder have smaller increments, which is very useful. Which will mean that it will be a bit smoother. Another issue is that if I turn this off and I rotate it, so let's just pull over, and if I just stop here, then let's say I rotate the wheel like this, okay, and I turn off. Let's say I'm going to bed right next day, and let's just wait for the power supply to turn off. Sometimes it takes a second. The capacitor's inside. Next day I turn it back on without centering the wheel, and we should reconnect any second. Okay, we reconnected, and suddenly this isn't the center anymore. Instead, this is the center. And the reason why is because rotary encoder, it doesn't change the value when it's disconnected from power. And one of the ways that commercial racing wheels fix that is there are multiple ways, but one of the ways I'm going to use is to get a magnet and a Hall effect sensor. So I'm going to place a magnet at the bottom of the wheel. So I'll place the magnet right here, which is the bottom part of the wheel, where this little, I guess, a divot is. It's a bit blurry, but the little divot is there. I'll place a magnet inset in there, a neodymium magnet, I don't know how to pronounce it properly, I think that's right. And I'll make a Hall effect sensor somewhere. And then I'll make it so I'll get a motor. I found a nice 12-volt DC motor, and which will be multi-purpose, as you'll see in a second. And I'll connect it there, and it'll just rotate, or just spin the axle around and around a bit, like that and like that, until it triggers the Hall effect sensor further higher than a certain threshold. And once it's done that, then it will say this is the center, and it'll reset the counter there. And it'll rotate it to the center point, and it'll stop. And then you can start playing without offsets. And that motor I can also reuse. So let me just reset this. Let me just fix this wheel. And all you have to do is disconnect it from the power or reset it. And the neodymium magnet, I'll do that in software instead of hardware resetting. If we reset it, now we have a normal wheel rotation. And as you can see, it takes corners nicely. But that will also help me with Haptics, the 12-volt motor. I'll have to find a specific motor that allows you to rotate it without damaging the motor. Because some motors, like screw motors, if you hold it down, right, at a high enough voltage, it'll break itself and it'll stop working. So I have to find a specific motor. I can change its direction, which is easy, and make it so I'll read. Because some games like BeamG Drive, Euro Truck Sim, they've seen data on like the wheel rotation on like haptics and stuff. And joysticks, they will just buzz a bit, right? Because they have a little vibrating motor inside. However, this I wanted to have an actual motor, like a direct drive motor. And I'll use a spur gear, and I'll attach a gear to the main axle to just rotate it. Appears we're going to crash. And that will mean it will rotate. I'll have haptics, and I'll kind of have to, if we crash or something, or the wheel gets misaligned, or I'll have to kind of fight the wheel to get it to rotate properly. And unfortunately, it won't be as powerful, obviously, as some of the proper direct drive wheels. Oh, by the way, I'll also before I do that, I'll also replace this with wood. And if I get a 3D printer, hopefully, then I will make it so that I can 3D print sections and replace sections. So if I decide to add another button there or something, then I can just 3D print a different section. Now thinking about buttons, I'm going to have a joystick controller for speed, but Euro Truck Sim, they have many different buttons for windscreen wipers and hundreds and looking out the window and all these different things. So I was thinking I could get my numpad, as you see here. I could get my numpad. I could figure out how if 3D printed something, maybe 3D printed, or somehow attach it or screw it in. I'll attach it to the wheel, like this. And that'll mean when I rotate it, I'll probably make the wheel a bit bigger. When I rotate it though, I can just press buttons, like let's say, because I already use it when using the keyboard. Because I already press 1 to look back. However, if I could do that mounted on the wheel, that would be pretty cool. Because if you see the real Formula 1 wheels or or some of the PlayStation wheels, they have tons of buttons, which is very nice. But yeah, that is the goal. Anyway, I think that's about it for the actual hardware. Now I can show you the software. So here it is. It's all in its 110 line glory. It's very simple. I have click and dat. Don't worry about button. That's not very important. It's just a little. There's just a button on the rotary encoder here. That's where if I was thinking maybe if I could mount it better, right? Then I could push this down and use it as a horn or something. But I'd probably just use numpad, since that button doesn't work very well, because the whole axle setup. Then I have up button and down button. These are these two buttons. I just have some Arduino wires that route itself over to the ESP32. I have count, which is the actual count. It goes from negative to positive. I don't know the range, but it's pretty much infinite. We have last state. That's not particularly important, just a bit of logic for the rotate state changed. I don't fully understand this switch case, but it does work, which is a great developer thing. Don't touch it if it works. But as you see, we have the binary, and we're just checking some cases of whether we should rotate the rotary encoder is going backwards or forwards. Then I have clamp, and this function I'm using it to clamp the value of the rotation. And then I'm doing count mapped, which I'm setting axis. Now up is 32,768 and down is 0, and rest is 16,384. And that's why all these axes are 16,000, etc. Then next I set it to count mapped as the axis, and I set it so that the throttle and accelerator and brake are just buttons, and I mapped them in BeamG Drive myself. And yeah, and then I do release if I haven't pressed either. Right, that's about it. I have done a bit of digital pin stuff, but yeah, nothing particularly special about the code. And I'm using BOE gamepad and Arduino IDE. By the way, if you plan on getting a microcontroller and you want something cheap and you don't need that many pins, I highly recommend you just get the ESP32C3. Brilliant chip. It has Bluetooth, it has Wi-Fi, Although apparently the Arduino version of it is better because it has a longer Wi-Fi range, because of a few technicalities. Anyway, I hope you enjoyed this video, and I'll see you next one. Bye!